Section 13.4 is about the law of sines. What you see here on this screen is not actually the law of sines, but it's something that works up to the law of sines. It's interesting to see that you can find the area of any triangle if you know two sides and the angle that's between those two sides. You can find that by using the formula that you see here. You're going to take 1/2 times the two sides times the sine of the angle that's between the two sides. So let's see what this formula looks like in action. Here's an example. I know what angle B is, and I know that the sides on either side of angle B are 6 and 5. So I can find the area of this triangle by doing 1/2 times the two sides, the 6 times the 5, times the sine of the angle that's between them, so the sine of 112. And so this is just a calculator problem. Type that in and find the area of the triangle. So here it is, and it's an approximate answer. 13.9 feet is the area of the triangle. So here you see what the law of sines is. If you take the relationship that we learned on the last slide and you play around with it using algebra, you can find that this proportion, these ratios occur, and we call these ratios the law of sines. And that's where you take the sine of an angle and its opposite side, and you can set that equal to the sine of another angle and its opposite side. And most often what we do is we split them up. And by splitting them up, we create these proportions. We compare A to B, A to C, or B to C. And the interesting thing is we can find the measures of parts of a triangle if we know two angles in any side, or if we know two sides and the angle that's opposite one of those two sides. Now we also have abbreviations for those. Here you see AAS stands for angle, angle, side, and that's when you have two angles and a side that's not between them. You can use the law of sines for that. We have ASA is when you have two angles and there is a side in between them. You can find that example. And then SSA refers to the example when you know two sides and the measure of one of the angles opposite one of those sides. So here we have a triangle ABC, and we want to solve this triangle, and we're going to use the law of sines to do that. Now the easiest thing to find in this triangle is angle B. We can find that because we know the measure of angle B has to add with the other two to be 180. So we can take 180 and subtract the 45 and the 55 and find out that angle B is 80 degrees. That's probably the easiest thing for us to find. And now we're going to use law of sines to find side A and side B. Well, let's look at angle A, which I do know. I don't know side A, so I can create a ratio, sine of A over A, and I can set that equal to angle C and side C, which I do know. So I'm going to plug values in, 3 of which I do know and 1 of which I don't know. So we're going to say the sine of 45 over A equals the sine of 55 over 12. And now this is just a proportion. I'm going to solve it using cross multiplication. So here we end up with A equaling 12 times sine of 45 over sine of 55. These are just numbers, so plug them into a calculator. And we'll round to the nearest tenth, so we'll say that A is approximately 10.4. Now we're going to do the same to help us find side B. We want to create some sort of a law of sines proportion. And so I'm going to use the B that I don't know, so I'll say sine of 80 over B, because that's the one I don't know, and now I need to pick one of the ratios that I do know. Well, let's stick with the C, sine of 55, or excuse me, sine of 55, because that's angle C, over 12. And then do the same thing, cross multiplication. So these are just numbers again, divide by sine 55, plug it into a calculator, and we get approximately 14.4. And so now I'm able to solve the triangle with 1, 2, 3 measures. Now when you're given an angle, and then two sides, where one of those sides is opposite the angle that you're given, there are some interesting scenarios that could happen, and that's what this key concept is trying to explain. Let's look at the ones over here on the right, because they're easier to understand, I think. If you're given an obtuse angle, then that means that that angle that you're given, since it's greater than 90 degrees, must be across from the hypotenuse. Well, if it's across from the hypotenuse, and you find out that the hypotenuse is actually smaller than the other side that you're given, That's impossible. You can't have that because if this was truly the hypotenuse, it would be longer than, in this case, side B. So you would say that something like that has no solution. You would not even have to do any work because you understand that relationship. Likewise, if you're given the obtuse angle A here, you know that it has to be across from the hypotenuse. All you then have to do is compare that leg or that side to the other side that you're given, and if it's bigger, then you can go ahead and solve it because you know that there's one solution to that triangle. Now it becomes a little more complicated when the angle that you're given is smaller than 90 degrees. There are 4 possibilities. So in this case, the angle is smaller than 90. What you want to do is compare the opposite side to this value b sine A. And that b sine A is kind of an important value that you're going to calculate. And if the side you're given that's opposite the angle is smaller than b sine A, you say that there's no solution. If the side that you're given equals b sine A, you know it's this triangle, so there's one solution. If the side that you're given is greater than b sine A, but smaller than b, then there's a possibility of 2 solutions because you can have that third side come down here to the left or go out to the right. So there's 2 possible triangles there. And then the last one, if it's just bigger, if the side across from the angle that you're given is bigger than b, then there's one solution. And we're going to try to look at all those different scenarios. But the key is to look for that b sine A and compare it to the side across from the angle you're given. So here's an example of a triangle ABC, and the angle that we're given is an obtuse angle. This is going to be a bad sketch, but I'm going to sketch it anyway. Something like this, where we're given that angle A is 118 degrees. So because it's obtuse, I want to go back to my chart here, and if it's an obtuse angle, I'm looking to see if the side across from it is smaller than the other side or bigger, because that's going to tell me if I have no solution or one solution. Well, I'm told that my A is 20 and my B is 17. So my side A, is bigger than side B. So we know from the chart that we showed on the last slide that we are going to have one solution here. So now that we know we're going to have one solution, let's go ahead and use the law of sines to find it. So I'm going to take the sine of angle A over 20, and I'm going to set that ratio equal to the sine of angle B over 17, because I know what 17 is, I don't know what angle B is. So using cross multiplication, I end up here. I'm going to plug this value into my calculator, which is about 0.7505, and that equals the sine of B. Remember, to get rid of sine, you're going to take inverse sine. So this is really the inverse sine of 0.7505, and that's what angle B is going to equal. And if I round, I get about 49 degrees for angle B. So fill that in. Now I can find angle C fairly easily. I know that angle C has to be 180 minus the 49 that I just found and the 118. So angle C is 13 degrees. That's the other part of the triangle that I don't know. And the last thing I want to find then is side C. And I can do that by, again, using the law of sines. We'll set up, let's go sine of 13 over C equals sine of 118 over 20. Using cross multiplication and then dividing, I find out that C is approximately 5.1. Here's another example, triangle with a 50-degree angle. So this is not going to be the obtuse case. This is going to be an acute case. So this will be A, this will be B, and this will be C. We know that this is 50 degrees. We know that side A is 5 and side B is 9. Now I don't really know side A yet. I don't know if it's too short. I don't know if it's long. I don't know what side A is just yet. So I'm going to go back to the table and see if I can find a relationship that tells me how many solutions are here. Remember from the table, the key is to look for that B sine A. B sine A and B sine A. That's the key. So I'm going to calculate that. So if I plug my values in and then plug this into a calculator, I get that this is about 6.9. Now, we were given an A value of 5, and we calculated B sine A as 6.9. So we actually know that our A value is smaller than B sine A that we calculated. So let's go back to our table. And if we look here, when the A value is smaller than B sine A, that means there's no solution. So this triangle is an accurate reflection. The side A is just too short, so we know that this triangle is not really a triangle. It has no solution. So in our last example, we're again given an acute angle for A. So we'll make this angle A 39. I'm going to put B over here on the right. I'm going to put C on the top. We know that side B is 14 units, and we know that side A is 10. But the interesting thing about this side being 10 is we don't know where it goes. We don't know if it goes out here or in here, and that's going to help us determine how many solutions there are. Remember, we want to compare this to B sine A. That's going to tell us a lot of information. Well, when I plug B sine A in, I'm going to get a value of 8.81. So notice the relationship here. First thing I want you to see is that side B, little b, is bigger than A. That's important. And then A is bigger than B sine A. That's also important because this relationship tells us something from the table. Here, we know that B was bigger than A, and we know that A was bigger than B sine A. So we now know that there are two solutions to the triangle on the other screen. Now, we knew there wasn't one solution because A would have been bigger than B in that case, and there would have been one, but it's not. There's two solutions. So we know that we're going to look for actually two triangles, and I'm going to try to draw those two triangles up here to let you see what I'm talking about. So here I've tried to draw the two triangles. There's one triangle where the angle B is here, and it's going to be an obtuse angle right here, and this side will be 10. Or there's the other triangle where angle B is here, and it's going to be an acute angle. And again, side A is still 10, and side B is still 14. But there's two possible triangles we have to look at, and we're going to have to solve both of them. Now, the first case we're going to look at is an acute angle for angle B. So we're going to take this bigger triangle here, and let's try to figure out what B is by using the law of sines. So the sine of angle B, which we don't know, over 14 equals the sine of 39, which we do know, over the 10. So using the law of sines, I can do cross multiplication here. So I get sine B equals this number. If I then take the inverse sine of both sides, I find out that angle B is approximately 62 degrees. Now that's the acute angle B for the big triangle case that I'm looking for. It's then fairly easy to find angle C because you're going to take 180 minus the 39 and the 62. So you find out that angle C is 79 degrees. And then the last thing I have to find is the side C. Now when I say side C, I'm talking about this big side triangle. I'll do it in blue here. This big side, because again I'm talking about the big triangle with the acute angle B. So we just figured out that angle C was 79, so I'm going to say the sine of 79 over C equals the sine of 39 over 10. Plug all that in your calculator and you get an approximate answer for C of 15.6 units. So that's case one. That's the triangle that you see on the outside, the big triangle with the acute angle B. So here we want to find our angle B, but we're not going to use the 62 degrees. We want to use the obtuse angle. Well, we want an angle that has the same sine value. So we're going to use 62 as our reference angle. If our reference angle is 62, we take 180 minus 62, and we get 118. So the obtuse angle that has the same sine as 62 is 118 degrees. So that's how we know what our angle B is for the smaller triangle. And then to find angle C, we take 180 minus the 39 and the 118. So angle C is 23 degrees, and then we can use law of sines to find the side C. Now, because I'm running out of room here, I'm just going to assume you can figure that out for yourselves. But in this case, we find side C is 6.2. So you see that there are two possible triangles, a smaller one and a bigger one with an obtuse B and one with an acute B. Over here is the acute angle case, and over here is the obtuse angle case.